Hi, friends. Welcome back. I feel like it's been a little while. Here we are in 7.4, still dealing with our rational functions. Remember, that's some polynomial divided by another polynomial. And today we are going to focus on multiplying and dividing those rational functions. So how do we simplify rational expressions with multiplication and division? And despite what you think, multiplication and division of these rational functions are actually going to be a lot easier than you think. They're definitely going to be easier than adding and subtracting, which we will tackle next lesson. So what I want to do first is just kind of review basic multiplication and dividing skills for just numerical fractions before we start using polynomials. So hopefully, as you know, when multiplying fractions, we are just going to simply multiply top to top, bottom to bottom. However, to make our life a little bit easier, remember you can cancel out or simplify diagonally before multiplying straight across. And then remember, when dividing fractions, you can, instead of dividing by a fraction, you can multiply by the reciprocal. So reciprocal meaning we flip that fraction. And that's exactly what we're going to do. When dividing fractions, flip this second, and then we're going to multiply straight across. So like I said, we're going to work with some numbers first before we get into those rational functions. So first problem we see is 22 over 27 times 81 over 44. So because we're multiplying these fractions together, we could multiply our top to top, bottom to bottom. However, for this particular case, 22 times 81 is going to be a really large number that I don't know off the top of my head. Same thing with 27 times 44. It's going to be just a little bit more challenging. So what I can do is I can make my life a lot easier. Being that neither of these fractions simplify, I can try to simplify diagonally. Okay, so when I see this 22 over 44, I know that simplifies into just a 1 over a 2. And then the same thing for that 81 over 27, I know that that is going to simplify. They're both divisible by 9, so then that would be 9 and that would be 3. And now I can multiply my 1/3 times my 9 halves and get a much easier situation here. So that's 9 over 6. And then, of course, I can still reduce to 3 halves. And there we go again. All right. Okay, let's try it again. This time we do have a division problem. So remember, whenever we're dividing by a fraction, we can multiply by the reciprocal. So I'm going to go ahead and rewrite it. So I have 7/6 times now 12 over 1. Again, I could multiply straight across and do my 7 times 12 over 6 times 1, get a number, reduce that fraction. Or I can simplify looking diagonally. I see that that 12 and that 6 will reduce to 2 over 1. And now it'll make my life a lot easier to say this is just 14. Okay, so the same exact concept, but now we're going to use those rational functions. Because we want to look at this idea of simplifying, we have to make sure it's factored first. Sometimes it doesn't have to be factored completely, but factoring is definitely going to help us see things that can cancel out. So what I see for example 1 part A is we have x cubed divided by x cubed minus x squared. Well, technically, when I look at that numerator, I technically cannot factor that. It's factored already. When I look at that denominator, though, I see that I could pull out a GCF of x squared, leaving me with x minus 1. Well, if my whole point of this is simplifying, wanting something to cancel out, I know that I could rewrite my numerator as x squared times x. That's the same thing as x cubed. So now what I see is that this x squared cancels out, and I'm just left with x over x minus 1. It's completely simplified, it's factored, nothing else will cancel out. All right, let's try that one more time. So in B, again, my numerator seems to be factored already. There's nothing I can really do. And that denominator, again, I see a GCF. Excuse me. So now I have 2x over x squared times 4x minus 1. Okay, and nothing seems to just immediately cancel out for us. However, I do know that this x to the first power can be divided by this x squared. Let me change colors. This x to the first power and this x squared can be divided. And then that's just going to give me x at the bottom. So now I can cancel out that and just have a 2 over x times 4x minus 1. 2 does not cancel out that 4. You cannot reduce that. We'll talk about why in just a little bit. So this is our final answer. All right, and then the last one, 2x squared plus 4 over 6x squared. So I definitely have a GCF of 2, leaving me with x squared plus 2 over 6x squared. I can't cancel anything out, but I can reduce these numbers. 2 over 6 does reduce to just 1 over 3. So now this is really just x squared plus 2 over 3x squared. And then that's my final answer. Again, these do not cancel out. I'll show you why in just a little bit. Okay, so here's the reason why. It says when you cancel out terms in a fraction, you have to factor first. Do not do what I just wanted to show you. Those x squares or those x cubed didn't just cancel out. You had to factor first. And here's why. It's easier to see with just plain numbers. If we look at the example of 2 divided by 4 plus 1, if you looked at this and you said, oh, I can simplify these to just 1/2, then that would technically get you 1 over 1 plus 1, which is 1 over 2. But we know our rules, 1/2. So then this would get you 1/3, excuse me. Okay, so this will get you 1 over 3. However, we should know our basic math rules enough to know that I would have to follow PEMDAS. Well, simplifying, you actually would work backwards. But anyways, this is the same thing as 2 over, what's 4 plus 1? 5. Can I reduce 2 over 5? No, this is my answer, not the 1/3, okay? Let's try it again. Same thing with the 6 plus 1 over 3. If you look at this and you say, oh, I can do 6 divided by 3. That's just 2. What's 2 plus 1? That's 3. No, that's not the right answer because really this is 7 over 3. Okay, so whenever you see something like this, you cannot scratch out those x squares. Whenever you see something like this, you can't do that, okay? And I think we've had this conversation a couple times in class, maybe not in yours specifically, but it has come up. So please, please, please be careful with that. You have to factor first. Like I said, sometimes you're going to factor a little bit differently. You might not factor all the way, but you're factoring, okay? So let's try some more. So now we're really getting into kind of piling it all in. So we're going to do some multiplication, and then we have some division problems. So remember, multiplying, we can just multiply straight across, top to top, bottom to bottom, and then simplify. If it's already factored, you can cancel out diagonally as well. So I would always try to factor first, see if anything cancels, and then multiply top, top, bottom, bottom. Well, in A, technically this is already factored. We're dealing with 2 different variables. So what I'm going to go ahead and do is I'm going to go ahead and multiply straight across and then do some simplifying. And in the second one, because it's factorable, we'll factor first, see if anything cancels out, and then multiply, just to kind of show you difference. So over here, I want to take it step by step. So 6 times 9 is 54. X squared times x to the 5th is x to the 7th. Y times y squared is y cubed. Over 3 times 2 is 6. X times nothing is just x. And then y cubed times y is y to the 4th. And so now we simplify. So I can simplify my constants, my x's, and my y's. So numbers, 54 divided by 6 is 9. X to the 7th divided by x is x to the 6th. And then y cubed divided by y to the 4th would be y to the -1, which means it goes to the bottom. Final answer, okay? Now there is an extra step here. Not only did we need to find the product, which we just did, we also want to list the excluded values. Okay, excluded values. You can never, ever have 0 in your denominator. Think about that undefined region, those vertical asymptotes, setting that denominator equal to 0. So anything that's in the denominator that would make the problem have 0 is going to be an excluded value. So for this case, because we're dealing with two variables, that means x cannot be 0 and y cannot be 0, because that's what's in my denominator here and here and here and here and here. It doesn't matter the exponent, 0 to any power is still 0. So whatever I plug in for that x and their y, they both cannot be 0, or either one of them cannot be 0. So this is also a part of my answer now. Okay, and this is going to be the case for multiplying and dividing. We're always going to either find the product and the excluded values or find the quotient and the excluded values. All right, so let's try it again. This one is one of the ones where we can definitely see that we want to factor first, and then maybe we can see if anything cancels out before multiplying everything straight across. So I'm going to go ahead and factor first. So in the first fraction or rational function, I know that there's a GCF of 5x, leaving me with 1 minus, leaving me with, 1 minus x, my brain just farted, sorry, over, and then x squared minus 4x plus 3. So I need factors of 3 that add up to negative 4. So that's going to be a negative 3 and a negative 1. Okay. And then in the second fraction, I have x squared minus 5x plus 6. So I need factors of 6 that add up to negative 5. So that's going to be a minus 2 and a minus 3 over just the 5x. I cannot factor that. So now that everything is factored, I'm going to go through and see if anything cancels diagonally or up and down. Cancels out. Cancels out. These do not cancel because really the numerator is technically saying negative x plus 1. So we need to be careful there. Those do not cancel. So now we're just left with the 1 minus x, the x minus 2 over x minus 1. Now we have to list our excluded values. This time there is only one variable, so I can go ahead and make a list. X cannot equal. Well, let's go ahead and look at the original function, the original problem. What was in the denominators? X minus 3, x minus 1, and 5x. With that, that means x cannot be 3, 1, or 0. Then I want to check my answer just to make sure. In my answer, the only thing in the denominator is x minus 1, which means the excluded value would be 1, which is already in the list, so we're good. So this is my final answer. Okay. All right. So now we're going to do division problems. All right. What I like to do is I like to rewrite my problem first, because instead of dividing these fractions, if you will, we're technically going to be multiplying by the reciprocal. So really we have here 7x cubed over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. Now I want to factor, cancel anything out, and then write my final answer with excluded values. So 7x cubed does not factor over 2 times x minus 5 times, I need factors of 30 that add up to negative 11. Oh, excuse me. So that's going to be 5 and 6. So a negative 5 and a negative 6 over x is the GCF, leaving me with x minus 6. Now I'm going to go through and see if anything cancels. X minus 5, x minus 5. Oops. X minus 6, x minus 6. Also, this x cubed here, there's technically 3 x's there, right? It's x times x times x. Well, if I take one of them and cancel it out with the one down here, now I'm just left with 2. So my final answer is going to be 7x squared over 2. So what I want to do now is I want to write my excluded values. Again, we only have one variable. So what can x not equal? X cannot equal. So I'm going to the original function, the original problem. What was in the bottom of those problems? This was in the bottom, and this was in the bottom, right? When we rewrote it, it became the top, but it was originally at the bottom. So that means x cannot be 5, 6, or 0. Sorry. Because we also want to check this bottom too. So in the bottom of the original, in the bottom of the rewrite, and double check our final answer. Which our final answer doesn't matter because it's just a 2 in the bottom. That one was kind of a tricky one. So that's why we're going to do it a couple more times. All right, let's start with yellow. Okay, so maybe this is a way that you want to do it instead. You have a couple options. What I did here first was I rewrote my problem as that multiplication and then factored. You could do the opposite. You could factor first, then rewrite. It's totally up to you. This one's a little weird because you know all of this is just over 1. So if I just factor first, this one I rewrote, then factored. This one I'll factor, then rewrite. So if I just factor first, for the first rational function, I need to factor my numerator. There's no GCF, so I need to find factors of negative, what is that? Negative 15 times 6. Negative 15 times 6. My brain is not working right now, so let's do this. Negative 15 times 6. 6 times 5 is 30. 6 times negative 1 is negative 6. Plus 3 is negative 3, so negative 30. That doesn't make no sense. Is that right? Why does my brain literally not work right now? 6 times... What is going on? Fifteen, 15, 15, 15, 15, 15. 5, 10, 15, 20, 25, 30. 1, 3, 4, 5, 6, 7, 8, 9. Okay. Why was that so hard for me? Wow. Okay. My bad. We need factors of negative 90 that add up to 1. That's going to be easy for us. That's going to be 9 and 10. And so we are going to want a positive 10 and a negative 9. Oh my God. Sorry about that. So I'm going to rewrite. So 6x squared plus, actually let's do the minus 9x plus 10x minus 15. Factor by grouping. Take out a 3x. Left with 3x minus 3. Take out a 5. Leaving me with, 2. Leaving me with 2x minus 3. So I have 3x plus 5 and 2x minus 3. Okay. See how important factoring is. All right. So I have 3x plus 5 times 2x minus 3 over 4x squared divided by GCF is x. So I'm going to take out an x, 3x plus 5, technically over 1. Okay, so if I'm thinking of excluded values, I can already say that x cannot be 0 because of this denominator right here. This denominator doesn't matter. There's no excluded values there because there's no variable. Okay, but now I need to actually solve this problem. So what I'm going to do now is keep the first, multiply by the reciprocal. And now I want to, again, if you want, look at your denominator, see if there's any new excluded values. This is still giving me 0. This is giving me 0. This is giving me a negative 5/3. So x can also not equal a negative 5/3. Okay. So now I actually want to see if anything cancels. 3x plus 5 cancels. And looks like that's about it. So now I'm going to multiply, and I get 2x minus 3 over 4x squared times x is x cubed. And there is no new domain restrictions, excluded values. So it's still just x cannot be 0 or negative 5/3. Final answer. Okay. And then the last one. And of course, I didn't really give myself a lot of room. So let me make this a little bit smaller. Oh. Can y'all hear this weather? I don't know if you can or not, but it's pretty crazy over here. Okay, for this one, for me personally, I just can't even understand what's going on. So for me, I want to go ahead and just rewrite it as x plus 1 over x squared, and that's being divided by x minus 2 over x. Now I get a better idea of what my problem is looking like, who's in my denominator, etc., etc. Lucky for us, there's no factoring that needs to happen. So what I'm going to go ahead and do is write out some excluded values. So right from the get-go, I know that x cannot be 0 because of this denominator and because of that denominator. Now I would factor, but it's already factored for me. So now I want to rewrite this problem as a multiplication. So x plus 1 over x squared is going to get multiplied by x over x minus 2. Again, I want to look at my domains and see if there's any domain restrictions. Why do I keep saying domains? Denominators. Look at that denominator, still an exclusion of 0. The denominator here is going to be an exclusion of 2. So add that to the list. Okay. And then the last thing I want to do is see if anything cancels out. And so for us, we cannot cancel the x plus 1 and the x minus 2, but I can cancel this x with one of those x's. And so now we're just left with x plus 1 over x times x minus 2, where x cannot be 0 or 2. Final answer. And that's it, guys. So whatever kind of floats your boat, if you'd rather rewrite the problem, factor, find the domain exclusions, or maybe factor first, look at excluded values, and then rewrite the problem and do your multiplication or whatever. It's probably going to be easier for you guys to do the way that I did for B and C, but maybe you followed along for A2, and if so, that's fantastic. Multiplication should be pretty easy, but like I said, just remember you always want to keep an eye out for those excluded values anytime your denominator is going to equal 0. So yeah, that's it. Hope you enjoyed my little brain farts throughout the way. And yeah, good luck multiplying and dividing.